Okay, so today we're going to look at how to take these greatest common factor and apply it. So if we are backtracking a little bit, factors are numbers that can go into another number. So they're the factors that go into it evenly with nothing left over. An example of a greatest common factor problem would be something like this. Jenny made 22 chocolate chip cookies, 36 oatmeal raisin, 63 peanut butter. She is making care packages for U.S. troops. If she wants to make as many identical care packages as possible, how many can she make? So this is a greatest common factor problem because we're taking the cookies and we're breaking them apart, right? We're sorting them out, kind of like you would think of in division, except for since we're breaking them up into even things with multiple numbers, it's not just one division problem, but like 3. Okay, so since we're breaking it apart, that's a clue to us that it is factors. So I need to find the greatest common factor between 72, 36, and 63. If I'm looking at this, I could make a big list of each and every one, but knowing my multiplication facts is helpful here, saying, okay, what numbers go into 72 and 63? They're 9 numbers apart, so I know that 9 is going to be the greatest common factor because it also goes into 36. If I didn't know that, I would probably start with the number 36 and then compare it here. So let's look at it that way. 36, I want to find the greatest common factor, so I'll list all the factors out. So 1 times 36 makes 36. 2 goes in because it's even, it ends in a 2. 2 times 18, and I do it like this, saying this is the largest number, and this is the smallest number. This is the largest number of my factors, and it's going to get closer and closer until I finally get in the middle and there's no numbers left. 3 goes into 36. That's going to be 12 times. 4 goes into 36. That's 4 times 9. 5 does not go in, and 6 times 6 makes 36, so that has to be my complete list. So I would look at this and say, okay, I know 1 goes into 63 and 72. I know 2 does. 3 does. 4 does not go into 63. 6 goes into 60, so it can't go into 63. 9 goes into both of them. Will not go into 63. 12 will not. 18 will not. No even number will go into an odd number. And 36 will not. So if I look at this, 9 must be my greatest common factor. So she can make 9 packages. Sometimes these questions are going to ask you like how many chocolate chip cookies, how many oatmeal cookies, and how many peanut butter cookies per packages. So in that case, I would look at 9 times 4 is oatmeal. So she'd have 4 oatmeal. 9 times 7 is peanut butter. And 9 times 8 is chocolate chip. So she'd have 4 oatmeal, 7 peanut butter, and 8 chocolate chip cookies. I hope I can get one of those, right? The next thing we're going to look at is applying the lowest common multiple. And multiples are like skip counting. They're the answers to multiplication problems. Joey has soccer practice every 3 days, basketball practice every 4 days, and piano lessons every 6 days. If he has all 3 today, how long until he has all 3 again? So there's a clue here that it says every 3 days, every 4 days, and every 6 days. So this saying, it's repeating over and over, 3 days, then 3 days later, then 3 days later, then 3 days later. That's what multiples are. So for soccer, I have practice 3, 3rd day, 6th day, 9th day, 12th day, 15, and 18. For basketball, I have it every 4 days, so that's on the 4th day, the 8th day, the 12th day, the 16th day, the 20th day. And piano is every 6 days, so that's 6, 12 days, 18 days, and 24 days. So if I look at this, you see they all have 12, so every 12 days will be my answer.